Hello, my name is David Bethune. Today, I'd like to give you a demonstration of some new technologies we've developed here at the Mimix company for working with text and facts inside of our text documents. At the end of the demo, I'll show you a preview of some new products we're building that include these technologies in everyday tools like word processing and wikis. Okay, just a tiny bit of background here before we dive into the demo. What's the problem we're trying to solve? We don't have fact checking. We have spell checking, we have grammar checking, they're everywhere. But if we read or write something that's factually incorrect, or we write something or read something that's changed, there's no easy way to fix that. So Mimix technologies are designed to solve this problem and bring fact checking and automatic fact correction to everyday tools like wikis and word processors. So getting to fact checking in everyday documents is going to take a couple specific steps. The first thing we did was build a new programming language called MSL that lets us mark up where the facts are inside of our documents. Just like we might mark up bold or a headline, now we can mark up where the facts are inside of the text that we read or write. This lets us tell if it's changed over time, and it also lets us go back and make corrections to things we've written in the past. The second thing we needed was a new kind of a database. We call it a hybrid database because it needs to keep the text from right now, as well as any changes that you've made to it in the past. And we needed a way to let other applications like word processors and spreadsheets interact with such a database so that they could pull facts in and out of their own documents. So those things together we call Nebula. Now, a great place to keep any kind of information for anybody is a wiki, and we know this because of Wikipedia, which is one of the most popular websites in the world. But Wikipedia doesn't have fact-checking. Mickey is a combination of our MSL fact markup and fact-checking technology and our Nebula hybrid database and viewer, which is going to bring fact-checking and fact-editing to wikis that you write for your own projects and for your company. And today I'm going to give you a demo of all three of these pieces of our solution. All right, here's the last slide before we jump into the demo. What we're going to be interacting with today is an MSL Viewer, and it's going to send us some MSL expressions that we write over to a hybrid database and get back the responses. Now, this viewer is really only intended as a testing tool and a way for us to show how the MSL language and the database work. It's not anything anybody would use in production. But I am going to give you a preview of how this underlying technology can power some new abilities inside of things like word processors and wikis. All right, what we're showing here is the Communicator. This is just the most basic viewer of all that lets us talk to the hybrid database, one MSL expression at a time, and give it information and then also find out what it knows. And I want to emphasize that these MSL expressions are not something that humans are normally expected to type. I'm just showing you this in a test mode. These are going to underlie the other applications that use MSL. So let's take the example of Walt Disney, as I like to do, and write an MSL example of what we know about Walt. We're going to store him in what we call an atom. And the database responds by saying, okay, I know about Walt Disney. We can inquire again about who Walt is, and he is Walt Disney. And we can even change his name to Walter Elias Disney and then inquire about him again. And the database should have that information, and it does. Now, we might also know about another person, Lillian, who's Lillian Disney. If I could spell, that would help. And the database now knows about her. We can also apply what we call metadata to Walt and say that, well, we know something about Walt, like we know his wife, and we know that she's this person. And indeed, Walt's wife turns out to be Lillian Disney. So if we just ask the database, who is Walt's wife, it's Lillian Disney. If we later find out that Lillian has changed her name to Lillian Mary Disney, and then we ask again who Walt's wife is, we should have her current name. So what we're showing here is just the most basic, lowest level of interacting with the hybrid database using atoms. Now I'm going to take this up to another level here in a second and show you how these could be built into paragraphs like we might find in a book or a web article. Okay, now let's look at how MSL expressions can be used to represent a more normal kind of paragraph text. And for this, I'm going to switch over to the testbed part of Nebula and write what we call MSL Text, which lets us look at evaluating several MSL expressions in a row. So let's say we were to come across a paragraph in a book like something like this. Walt is his own atom. Walt Disney was an American inventor born in, and we're going to also keep Walt's year of birth as its own entity here, his metadata, and also where he was born. And that place where he was born is its own atom. Chicago is certainly a big enough entity that it would get stored as its own atom. Chicago, Illinois. That's Walt's birthplace. He was married to, and we're going to say that his wife is also an atom by herself. And her name is Lillian Disney. If we send this out to the database, what we're going to get back is that Walt Disney was an American inventor born in 1901 in Chicago, Illinois. He was married to Lillian Disney. So this is what you would find inside of the beginning of an article in a magazine, for example, although the underlying data is all stored separately in the hybrid database. So how do we know that? Well, let's go ask. Let's ask it, who is Walt? And I'm going to show you a new little syntax here for saying what we would expect it to say. We expect Walt to be Walt Disney. And who is Lillian? Well, she better be Lillian Disney. And what is Chicago? It should be Chicago, Illinois. So let's run this and see if that's true. And indeed it is. Walt is Walt Disney, Lillian is Lillian Disney, and Chicago is Chicago, Illinois. And all of those were extracted from this one paragraph by marking up that paragraph using MSL. One challenge in working with facts in text documents is that oftentimes the same facts are represented with different words. For example, Walt, Walter, Elias Disney, and Walt Disney all refer to the same person. Also, we often have a need to search and replace things that have different words, but all mean the same thing, or we want all updated to the same thing. So let's look at some ways that MSL can handle that. We already have the P1 that we wrote before, that we know about Walt and his upbringing and wife. If we were to write a new paragraph 2 and to rephrase his last name in the original family name, all we have to do is recall the P1, and we're going to send it through to, in this case, regular expressions. You can chain these outputs from these MSL expressions into any other language right here, just like I'm doing with regex, but to show you a simple search and replace, I'm just going to use regex here. And we're going to replace Walt Disney with Disney, his original family name from France. And when I get back P2, it should say Walt Disney was an American inventor. He was married to Lillian Disney. Now, P1 has not been affected by that at all, and neither has Walt, and neither has Lillian. So let's make sure that that's the case. Their original names are still there. So this shows how we can take, in this case, a regex expression and apply it to some value of an atom or its metadata and transform that in the moment when we need it in a paragraph, but not affect it otherwise. And this is a small form of data protection. There's another larger form of data protection provided by MSL called canon that protects an overall value that we know throughout the institution or throughout a document. I'm not going to demo that in this video, but this is an example of exactly how that works. So often with business facts, we need to do two kinds of changes to them. Sometimes we need to make a change that's a one-time change to fix a typo or bring something in line with the other versions that we have. And other times we need to make a generalized change and hoping that all the versions going forward will have that same kind of change. So let me show you how that's represented in MSL. So here we've set up Walt Disney as an atom, and we've given him a birthplace of Chicago, Illinois, but I've run this one-time program on it, a regex program that strips off the part after the comma, just leaving the city and throwing away his state. So I might use this in a sentence or in a data record where I just needed the city portion, for example, printing a mailing label. If I were to later assign Walt a new birthplace of Baton Rouge, Louisiana, that program does not run, and I get back the full birthplace as I specified it. Well, what if we did need it to run again in the future and not have this be a one-time change, but a going forward change? We can define a new piece of metadata for Walt, his city, and say that his city is his birthplace with this regex program on it, which removes everything after the comma, giving us just his city. And keep in mind here that I'm just showing you the simplest example. This program that goes in here can be any kind of external program through what we call formats, and I'm going to show you that in the next example. The most important part to know here is that if I were to give Walt a different birthplace of Chicago, Illinois, with a state and a comma on it, the city metadata runs the regex program and brings back the city only. So this shows how regex expressions can abstract over values, is how we refer to it, to apply changes going forward to a value that sits in another piece of metadata. All right, so let's run this and see if this works. So indeed, when we ask for Walt City here with the regex expression on it, we get back Baton Rouge without the comma or the state. And when we change his birthplace to Chicago, his city also does not have the comma or the state. Now, just to kind of finish the example here, let's make sure that Walt's birthplace hasn't changed. It should be Chicago, Illinois. And indeed it is. So working with facts in our existing documents introduces a couple of other issues. One is that a lot of those documents aren't documents. They're videos, they're spreadsheets, they're audio files, or other unique formats. If we're dealing with scientific experiments or historical data, we may be looking at other different kinds of file formats. The second problem is that we need to know how to display things in the viewer in a couple different ways, and that's really up to the application. We may want to look at the same data as a map or as a timeline or a biography or a bibliography, and how do we handle that with MSL data? The third problem that comes to mind is that a lot of this data is going to be on other files on your machine or on other people's machines or on the web. So how do we relate MSL data to things that exist on the web or on drives? So let me show you how we deal with kind of all of those examples at one time. Let's say that we're going to create an animated character here, and his name is Donald Duck. And we're going to give him a custom data type that we define of an animated character. That's completely up to us what that means in our application, but at least the database knows how to store that when you send that over. In other words, the fields or format requirements for that are defined by your application, but these are going to be supported for the Donald atom going forward. The other thing we might want to do is we might want to show Donald in terms of some special format that our viewer supports, like a timeline of everything that we know about him. We also might keep some image information from him, like a thumbnail picture, but that is not here. That's located on, let's say, our website at Donald's PNG. And as a fallback, if the viewer doesn't support PNG, let's say we have another potential image source, and we would like those images formatted in our viewer. Oh, let's do one more thing. Let's tell it that those data types on the server in the engine are images, and that in the viewer we'd like them formatted as a thumbnail, and we don't want the thumbnail any wider than 500. All right, let's run this and see what we get. So in a narrative text talking about Donald, this would be named Donald Duck. So that's what comes back on the admin wire. The Donald wire, however, knows quite a few things about this that can be used to build a different view of him in the viewer and store his information differently in the server. So if we were to inquire about Donald's image, for example, we would get back the URL to the preferred image for his picture. And we're told here in the return MSL that it is expected to be a thumbnail. That's going to be processed by the viewer. So this is quite a leap, I realize, from what we've looked at already. But I want to show you how data types and formats are built into the language, and this gives a lot of flexibility into how application developers can handle unique kinds of data and data sources from disks or network sources. So while we were building Nebula and MSL, we needed a place to document it, and we decided to use a wiki, just like you'd find at Wikipedia. It's a great way to keep live edits updated across the team and to have a place where the public can access technical information. We wrote all of our language documentation in the wiki format, and we used graphs and cross-references and things to try to make this really easy for users to get around and understand our language. Along the way, we realized that the wiki also has all of these fact-based problems. If I've changed something about the definition of something in our language, there's no easy way to update all the references to this across the wiki. If I have changed this source code example, there's no simple way to make sure that all the other related examples have the same change. So if I'm developing a language or a software product or a complex engineering product or a process diagram, there's no way to keep the wiki updated across the various pages and parts. And that's a huge shortcoming that we're going to fix. So Mickey, the Mimix wiki software, is the first tool to take wiki software that everyone understands and bring our MSL fact-checking and updating to it. So we're going to add to this wiki software that we're already demoing here the ability to mark things in this text as facts and then to find where all those facts are and change them as they change across the enterprise. So if the enterprise dictates that a picture such as this needs to change, Mickey's going to change it everywhere, or at least offer to give you the chance to do that and to see where those changes are. If you're defining a process for putting together a complex product, an engine for an airplane, and you have process diagrams or language statements or procedures, including complicated procedures for developers, complicated diagrams and instructions for interfacing with the customer, software examples, text code in your own language. By the way, another feature of Mickey is to allow you to run all of these external code examples in whatever your own engine or process is. These are all dispatchable outside. So this kind of technical documentation that's critical to the enterprise is a great use case for Mickey and MSL because we're going to bring the ability to mark these things. Just like today, you can mark them as bold or mark them as a headline using simple markdown formatting with a live preview over here as you make changes. We're going to bring that same ability of the text editing to the fact editing world. So that, in a nutshell, is the product release and should give you, I hope, a small example of what can be done with our forthcoming technology. So shortly, we'll offer the Mickey Wiki product, as I've just shown it to you, as a hosted service and a downloadable service that users can install and run themselves. Following on that will be Mickey with the MSL features that we've talked about to allow users to mark up facts as they write them and also to mark facts in old documents. And then the wiki software can automatically compare them, let you fix them, update them, change them across your documents as you choose to. The next evolution of Mickey is Mickey with Draw.io. That's an open source platform for diagramming inside of JavaScript applications. We're going to fold in the Draw.io technology into Mickey and allow users to draw diagrams live and experience all the same updating, fact-checking, diagram updating capabilities that the MSL language provides for text, but now with engineering, process, HR, scientific, chemical diagrams, etc., of the user's own design. The final phase of the evolution of the Mimix product line is Mimix as a word processing replacement. So evolving from the markdown-based user interface that you see here in Mickey today to a more traditional word processing interface and incorporating PDF, Word, plain text documents, and allowing for print document composition and things that users expect in a word processor today. So that's all I have for you today. I'll conclude by showing you this slide of Vannevar Bush, the inventor of the Mimix machine, after which our company and our product is named. It was Bush's hope that such a device could help people to learn to think better, and that's my hope as well. I invite you to visit this special website, wiki.mimix.io, which is a running example of our wiki and shows many examples and demonstrations of how our language can be used. I also invite you to download Nebula for yourself. It works on Linux, Mac, and Windows machines and is available for you to open source, experiment with, and use in your own projects. Feel free to contact me. My email is david@mimix.io, and I appreciate your time today and look forward to hearing from you. Thanks.